All right, in today's video, we're going to be talking about 14.4, which is adding and subtracting with rational expressions. All right, first example is we're going to add x over x squared minus 25 plus 5 over x squared minus 25. Now, in the past couple of lessons, we've been talking about least common multiples, finding the right denominators to be able to add them. So for us to actually add and simplify rational expressions, they have to have the same denominator. Now, in this case, they are both the same. So that means that our answer will be x squared minus 25. And then from there, we can then actually do the top part of the answer, which is then x plus 5. Now, they want us to also simplify this. The best route to do this is to then use our factoring techniques and realize that x squared minus 25 is a difference of squares. Or realize that you're trying to find two things that multiply to negative 25 but add up to 0 since the b is missing, which would be x plus 5 and x minus 5. Those two numbers multiply to negative 25 and add to 0. If you remember my trick as well, if I'm trying to add to 0, these two numbers need to be the same with opposite numbers. So the goal is just trying to figure out what number multiplies to 25. In this case, then the x plus 5 would cancel. Remember, if everything cancels, there's still a 1 left. So your final answer is 1 over x minus 5. But on your homework, on some of them, not all the questions, it will still ask what answers can x not be. And remember, you're going to set the denominator that you factored here equal to 0. So x plus 5 equals to 0 and x minus 5 equals 0. So I would subtract 5 and I'd get x equals negative 5. Then I would add 5 and I would get x equals 5. So these are the things that x cannot be. So you simplified it, or you added them, then simplified from what we did in 14.2, and then you found out what x cannot be from 14.1. All right, so this was actually part A. So let's look at part B to give us another example to work out. All right, this one is 2 over x squared plus 8x plus 15 plus 3x plus 7 over x squared plus 8x plus 15. Again, the denominators are the same. So I can go ahead and rewrite the denominator as is. I don't actually add the denominators. Got to make sure they're the same. And then I can actually do the operation on top. So I have 2 plus 3x plus 7. So the 2 and the 7 can combine, which will give me 3x plus 9. And then now we're back to 14.2, in which all you have to do is factor, cancel, and you write what's left. And then again, determine what x cannot be. So in this case, I could factor out a 3 on top. That's my greatest common factor. So take out a 3, and I'll divide each thing by 3. And 3x divided by 3 is just x. 9 divided by 3 is 3. And then on the bottom, a trinomial always factors into two binomials, where the leading term will be an x. And then you just determine what two numbers multiply to 15 and add up to 8, and that would be positive 3 and positive 5. So everything's now factored. So now I'll cancel the x plus 3, and then I'll write what's left, which is 3 over x plus 5. So that's your first part of the answer. And then you have to take this part and you have to determine what x cannot be. So here's x plus 3 equals 0 and x plus 5 equals 0. So x cannot equal -3 and x cannot equal -5. So those are what you have to do. Now, after I think like the first couple of questions, the rest of the homework just tells you assume that the no denominator has a value of 0. So all you have to do is just work on the actual math rather than stressing about what x cannot be. So let's see some of these examples. So on number 2, our A, we're going to look at x over x plus 2 plus 3 over x plus 3. Now notice these two denominators are not the same. So we would factor them first, but they're already factored. So because this is an x plus 3, I would need to then multiply this x plus 2 by the x plus 3. And since this is an x plus 2, I need to then multiply the x plus 3 by x plus 2. Now by doing that, the denominators are now the same. The only issue is what you do to the denominator, you must also do to the numerator. So if I multiply the bottom of this fraction by x plus 3, got to multiply the top by x plus 3. If I multiply the bottom of this fraction by x plus 2, I got to do the same thing on top. This is basically multiplying by a fancy 1. So we're not changing the value of the expression, we're just manipulating it. So now when we do this work, the x plus 2 and the x plus 3, we can just write that down one time. Because now the denominators are the same, and it doesn't matter the order either. One thing I did notice on y'all's homework, let me verify my notes here, is they did not fold these out. They actually left them like this. So I recommend the same thing. So just gives you less work to have to do. Now I'm going to go back and do the work. So x times x is x squared. X times 3 is 3x. 3 times x, so there's a plus sign here, so plus is 3x. And 3 times 2 is 6. Combine like terms there. That's going to give me x squared plus 6x plus 6. And then I have x plus 2 over x plus 3. Now, as long as we're multiplying by the least common denominator, which in this case we are, we won't have to worry about going any further, but you could try to factor if you could. But in this case, there is nothing that multiplies to 6 and add to 6. There's only two things that multiply to 6, and that's 1 and 6 and 2 and 3, and neither one of them add to 6. So this would be your final answer. Now, if you could factor, you would definitely try, and then you would cancel and write what is left. Let's do another one. Let's try part B. This one is 1 over x squared plus 10x plus 25 plus 1 over x squared minus 25 plus 1 over x plus 5. So the first thing you want to do is factor everything. So I'm going to factor this trinomial first, which I know factors into two binomials with a leading term of an x. And I ask myself, what are two numbers that multiply to positive 25 but add up to 10? And in this situation, that would be plus 5 plus 5. I'm going to cross this out because this has now became this. This right here is a difference of squares, or a same concept of multiplying to negative 25 but adding to 0. We did this one earlier. So remember, when you're trying to add to 0, that tells you both numbers have to be the same. So the only two things that multiply to 25 that are the same is 5 and 5. And then one would be a plus, one would be a minus. And that will go away. And then this is x plus 5 cannot factor. So I got to figure out what everybody has that they're missing something. This one has 2x plus 5s. This one only has 1. So I need to add another x plus 5. And now this one is now missing an x minus 5. And then over here, I have 1x plus 5, but I'm missing another x minus 5 and an x plus 5. So now that I've got all three denominators the same, one thing I have noticed is they won't write x plus 5 and x plus 5 twice. And we found a simpler way to do that. They'll just say x plus 5 squared and then x minus 5. So now they're all the same. The only kicker to this is what I do to the bottom, I have to also do to the top. So if I multiply this bottom by x minus 5, I have to multiply the top by x minus 5. If I multiply this bottom by x plus 5, I have to multiply the top by x plus 5. If I multiply this bottom by an x minus 5 and an x plus 5, I gotta do the same thing to the top. Now when I do that, 1 times that is just x minus 5 plus x plus 5 plus this right here. I can actually FOIL out or notice that this is the same thing. So I'm going to just see that and I'm going to go, well, that's just the same thing as x squared minus 25. And then now we write our final answer. So the 5's here would cancel. So I have x squared plus 2x minus 25 over x plus 5 squared and x minus 5. And again, you just keep it like that. Don't try to factor anything because there's not two. Typically, there are some situations, but typically there's not two things that will multiply to that c and add to that b. Do check if you need to or if you can. In this case, again, nothing that multiplies to negative 25 and adds to 2. So that's my final answer. Alrighty, so like all homeworks, it progressively gets a little harder. So let's look at some different ones. So number 3, it asks us to find the sum, reduce if possible, and assume no denominator has a value of 0. And all that simply means is we don't have to actually go calculate what x cannot be. We can just worry about the work. Now, if you thought it was confusing with an x, they do try to change the letters. So they'll say this is s over s plus 3 plus 4 over s plus 1. But it's the same work as with an x. So I see that they're both factored. So since this one does not have the s plus 1, I'll multiply by s plus 1. And since this one doesn't have the s plus 3, I'll multiply by s plus 3. And again, whatever I do to the bottom, I must also do to the top. So again, now the denominators are the same. So I'm going to write them out once. So s plus 3, s plus 1. The order doesn't matter. And then I'll distribute out. So s times s is s squared. S times 1 is s. 4 times s is 4s. And 4 times 3 is 12. Combine the middles there. So that's s squared plus 5s, because there's like an imaginary 1 here, plus 12 over s plus 3 and s plus 1. Again, check. Two things that multiply 12 but add up to 5. I can't think of anything. Yeah, 1 and 12, which is 13, 2 and 6, which is 8, 3 and 4, which is 7. So this case, this would be my final answer. All right, let's go a different route with it now. So number 4, it says now we're going to find each difference. Same process as adding. The only difference is you're subtracting. So this is now going to be 4x minus 7y over 3x minus y minus 3x minus 9y over 3x minus y. So make sure the denominators are the same, which they are. So I'm going to write that down once. So 3x minus y. This is part A, by the way. Once I determine that they're the same, key thing here is subtraction. So when I'm combining like terms, this becomes 4x minus 3x, which would just be x. And then this is negative 7 minus negative 9. If you need to write it out, write it out. So that's negative 7y minus negative 9y. Those two negatives right there are going to produce a positive. So this is really what is -7 plus 9. So if you owe someone 7 and you have 9, when you pay them back, you will have $2 left. So that becomes 2y. And again, that would be your final answer. Right, so that's the only difference with subtraction. When I'm combining like terms, I'm subtracting the stuff from the right. All right, let's try another one. Let's try B. This is x squared over x squared plus 6x plus 9 minus 2x plus 15 over x squared plus 6x plus 9. Again, the denominators are the same. So write them down as is, and then do the math on top. X squared has nothing to combine with. There's no x's here, but it's going to be a 0x's minus 2x, which will give me -2x. There's no constants here. I'm still subtracting a 15, so that'd be -15. Again, you could try to factor. I think these actually do factor. The two things that multiply to 9 but add up to 6 would be x plus 3, x plus 3. And two things that multiply to -15 but add up to -2 would be x minus 5 and x plus 3. That gives me -15 and adds up to -2. I can then cancel, and my final answer would be x minus 5 over x plus 3. So do watch out. Factor when you can. All right, one more of these types, and we'll go a little bit harder. Let's look at part C. This is x over x minus 4 minus 5 over 4 minus x. So the denominators are almost the same, but they're just flipped. Remember, when that happens, I can factor out a -1, and it would flip the terms around and still have the minus. But since it's already being a subtraction, this negative will now make this problem a plus. So I end up now with x minus 4 plus, because I factored out this negative, 5 over x minus 4. So again, the denominator is very similar. So I pulled out a negative, and when I did that, it flipped it, but then it also changed the operation. So the answer to this one, if the denominators are now the same, I would write that on the bottom. And on top is just simply x plus 5. So in this case, I get x plus 5 over x minus 4. All right. So let's step up our game. And on part 5, it says find each difference and reduce if possible, and assume there is no denominator that has a value of 0. So we have x plus 6 over x minus 6 minus 144 over x squared minus 36. All right, we start off by factoring. So I have x minus 6, can't do anything there. This is x squared minus 36, so I'm trying to come up with two numbers that multiply to -36, but add up to that 0. And hopefully you see that that's x plus 6 and x minus 6. So again, just like with the addition, I notice that this is missing the x plus 6. So I will multiply by the x plus 6, but if I do it to the bottom, I have to do it to the top as well. So now that the denominators are the same, I can write it down once. Again, no need to actually multiply them out. All right, and then I'm going to work out the top. Now this is x plus 6 times x plus 6. So that right there will end up being x squared. plus 6x plus 6x plus 36 minus 144. That's a minus 144. So now I'm just going to simplify this up. That gives me x squared plus 12x when you combine 6x plus 6x. And then 36 minus 144 is 108. Yeah, actually, sorry, negative 108. So now I'm going to think, all right, is there two numbers that multiply negative 108 and divide or add up to 12? So you got 2 and 54. 3 goes into 108 36 times. 4 goes into it 28 times. 5 doesn't go into it. 6 goes into, see, 6 goes into 108. 1, 8, 18 times. Oh, yep, there it is. So it'll be 6 and 18. So that'd be x, 6, 18, which multiplies to 108. One needs to be positive, one needs to be negative. So I want the 18 to be positive and the 6 to be negative. And then now I can see that my x minus 6 will cancel. And I'm left with x plus 18 over x plus 6. So once you get through the new stuff, when you get to this point, you're doing what we did in 14.2 and you're factoring, canceling, and writing what is left. All right, that was just part A. Let's look at part B. We have 5x plus y over x plus y squared minus y over 3x squared minus 3y squared. Right? Start off by factoring first. And the only thing I can see I can factor out, I would leave this as is. Or what might be better, rewrite x plus y squared as x plus y times x plus y, just so you can make sure that you know everything that you have over here. Over here, I notice that they both have a 3 in common, so I'll divide them all by 3. That gives me x squared minus y squared. Hopefully you can notice this. They're two perfect squares with a minus sign in the middle. This is a difference of squares. So that would factor into two binomials. Then you just take the square root of each. So the square root of x squared is just x. Write it down twice. Square root of y squared is y. Write it down twice. One with a plus, one with a minus. So this all turns into this. So I already have 1x plus y, but I am missing the 3 and an x minus y. Now over here, I'm still missing 1x plus y. So there's my common denominator. I'll go back and I'll write that as x plus y squared, because that's what your homework's going to want you to do, and then x minus y. So again, what I do to the top, I have to do what I do to the bottom, I have to do to the top. This is a 3 and an x minus y. And this right here would just be an x plus y. So it doesn't matter how you multiply this. You can do the 3 first to FOIL this out. I think I'm going to FOIL this out first. So this will give me, put 3 on the outside. 5x times x is 5x squared. 5x times negative y is negative 5xy. Y times x is a positive xy. I go alphabetical when I multiply letters. And y times negative y is negative y squared. And then I'm just going to rewrite this. So I'm going to have to do a whole bunch of distributing anyways. And then I can say that my next answer, I would say final, would be 15x squared minus 15xy plus 3xy minus 3y squared minus xy minus y squared all over 3 times x plus y squared times x minus y. So now all I'm going to do is just combine the top. So I have a 15x squared minus, oh, those are all y's. So I'll just leave it as 15x squared. I have a negative 15xy plus 3xy will give me negative 12xy. And then this would give me back to negative 13xy. And then this is a negative 3y squared and negative y squared. So that'd be negative 4y squared over all of this. And let's see, I wrote some notes down on this one. Yep. And your homework just kept it like that. There was no need to try to factor tree all these multiple letters and everything. You're good right there. All right, let's do a few more. Let's look at part C. Part C had 4x minus 8 over x squared plus 4x minus 12 minus x squared plus 6x over x squared plus 9x plus 18. So I'm going to factor the denominators first. So a trinomial will always factor into two binomials where the leading term will be an x. And then it's got to determine two things that multiply to negative 12 but add up to 4. I come up with 6 and 2. And this would be positive and this would be negative. Do the same thing over here. So trinomial factors into two binomials where the leading term is an x. So it multiplies to 18 but adds up to 9. It'd be 6 and 3. All right, so I notice this one is missing the x plus 3, and this one's missing the x minus 2. So now I'm going to write them all out. So x plus 6, x minus 2, x plus 3. There's my denominator. Of course, what I do to the bottom, I must do to the top. All right, so I got 4x times x, which is 4x squared. 4x times 3, which is 12x. Negative 8 times x, which is negative 8x. Negative 8 times 3, which is negative 24. Minus, I'm going to leave this in parentheses so I can do the math over here. X squared times x gives me x cubed. X squared times negative 2 gives me negative 2x squared. 6x times x gives me 6x squared. And 6x times negative 2 gives me negative 12x. And I left that in parentheses so that when I come to combine like terms, I can see that I'm subtracting. So there's no cubes over here, minus x cubed. So I have a negative x cubed. Then I have 12x, oh, not a square. So I have 4x squared minus negative 2x squared. So that would become, well, let me do this. Let's clean this up just a little bit. I know that negative 2x squared and 6x squared is just 4x squared. So when I look at 4x squared minus 4x squared, I can see that they would cancel. I then have 12x minus 8x. That's 4x. So 4x minus a negative 12x. So a negative 12x That would be a positive now, so that would give me 16x, and then I just have a negative 24. And then I just have my denominator. So x plus 6, x minus 2, and x plus 3. And again, because that's a cube, we can't try to factor that any further because y'all haven't quite learned how to do those yet. Alrighty, I want to pause. Let's see, make sure I did my math right here. Did I write it down right? Oh, okay, so that seems all right. Maybe I combined it wrong. So I had the negative x cubed, then the square. This would be negative 2x squared plus 6x squared, which is 4x squared, and then 4x minus 4x would just cancel. And then 12 minus 8 is 4. 4 minus a negative would make it a positive 12. So it'd be 16. And then it's just a negative 24. Hmm. Oh, I didn't even see that at the very beginning. They factored the top as well. Gotcha, gotcha, gotcha. All right. Well, lessons learned on this. And the issue is because I didn't factor the and simplify before I started the process, I didn't get to see what the product would look like at the end either. We don't know how to factor trinomials yet. We haven't learned that part. All right, so let's start back at the beginning. We got this factored, but we also need to factor the top. We haven't came up with this situation yet, so I'm glad we came up with it here before you saw it on your homework. So 4x and 8 all have a 4 in common. The greatest common factor is 4, so I have x minus 2 left. So actually my x minus 2's would cancel. I can only do that with the current fraction I'm looking at because of the subtraction I can't go across. So now this becomes 4 over x plus 6. And then here I can factor out an x, and I'm left with x plus 6. So then I just divide each one of them by x. And then the x plus 6 cancels. So then I have minus x over x plus 3. By doing that, it actually makes the problem a lot easier. Because now all I have to do is multiply this one by x plus 3 and this one by x plus 3. And then multiply the bottom of this one by just x plus 6. So now my denominator is x plus 3 and x plus 6. 4 times x is 4x. 4 times 3 is 12. And then this negative here will be attached to the x. So when I distribute, it becomes negative x squared and negative 6x. So that when I combine like terms, we write the negative x squared first. But 4x minus 6x is negative 2x plus 12 over x plus 3 and x plus 6. A lot more simple when we simplify before we start working. So lessons learned. All right, let's look at part D. So we have y plus 4 over xy minus 2y plus x minus 2 minus y minus 5 over xy minus 2y plus 3x minus 6. So remember, when we factor with 4 terms, we factor by grouping. Xy and 2y have a y in common, so I'm left with x minus 2. X minus 2 can always be factored by a 1. I'm left with x minus 2. And then they both have an x minus 2 in common, so I'll factor that out. And then I'm left with y plus 1. And because of that, the y, that's a plus 4, correct? Yep. So I can stop there. Here, I'll factor by grouping. They both have a y in common, so I'm left with an x minus 2. Here they have a 3 in common, so I'm left with x minus 2. So I can factor out an x minus 2, and they're left with a y plus 3. So that's what this turns into. So I can then see, I cannot cancel anything. Everything's factored. So then all I have to do is go, all right, I'm missing a y plus 3 here, and I'm missing a y plus 1 here. Do it to the top. So now on the bottom, I have x minus 2, y plus 1, and y plus 3. And then I'll fold these out. So it becomes y times y, which is y squared, y times 3, which is 3y, 4 times y, which is 4y, and 4 times 3, which is 12, minus parentheses, because I want to be able to know I'm subtracting. Y times y is y squared. Y times 1 is 1y. Negative 5 times y is negative 5y. And negative 5 times 1 is negative 5. Combine like terms, y squared minus y squared cancel. 3y plus 4y gives me 7y. Y minus 5y gives me negative 4y. So 7 minus negative 4, that would make a plus 4 now. So that gives me 11y. And then 12 minus a negative 5, so that becomes a plus 5, gives me a plus 17. And there you go. All right, let's do a couple more, and then I think y'all will have everything y'all need to be successful on this homework. So let's look at number 6. 6 says, find the difference and reduce if possible. Assume that no denominator has the value of 0. So we have x minus 4 over x squared minus 2x plus 1 minus 5 over x minus 1. So I factor everything that I can. The only thing I can factor. So a trinomial factors into two binomials where the leading term is an x. Two things that multiply to 1 but add up to negative 2 would be negative 1 and negative 1. So I see that this is missing in x minus 1. And therefore now they're the same. And so I have x minus 4 minus will be attached to this 5 as I distribute. So that'd be negative 5 times x, which is negative 5x. Negative 5 times negative 1 will give me that positive 5. X minus 5x will be negative 4x. -4 plus 5 would be +1. And then they'll want you to write it as x minus 1 squared. And that's it. All right. At the very end of your homework, it tries to confuse you, or try it. That's not gonna be successful because you're gonna get this down. But it's gonna have subtraction and addition. So we have 9 over 25 minus y squared minus 2 minus y over 5 minus y plus y over 5 plus y. So again, this is a difference of squares. Hopefully you're getting better at this one. Going to factor into two binomials. Take the square root of the first one. So square root of 25 is 5 and 5. Square root of the y squared. So that's going to be y and y. One with the plus, one with the minus. So then I notice that this one's missing the 5 plus y. And this one's missing the 5 minus y. So then I have my 5 plus, 5 plus y and 5 minus y. Again, it does not pull it back out. This I didn't have to multiply by anything, so it's just a 9 minus, make sure I carry this 5 plus y here, and this 5 minus y here. Got minus, and then I'm going to go ahead and distribute, but I'm going to leave it in parentheses. So 2 times 5 is 10. 2 times y is 2y. Negative y times 5 is negative 5y. And negative y times y is negative y squared. Distribute. So plus 5y minus y squared. I have to put this in parentheses because it's a plus. So it gets to keep the sign. So now as I combine like terms, I'll go ahead and combine these. 2y minus 5y is negative 3y. We'll start with the square first. This is a negative or a minus a negative y squared, which makes this a positive y squared. So positive y squared minus y squared would actually cancel each other out. And then this becomes a minus a negative 3y. So it's actually a positive 3y that will add to 5y and give me 8y. Then this is a 9 minus 10, which will give me negative 1. If you have to write it out or do you change in the signs, do that process, whatever makes it easier for you to see that. Other than that, that is it in 14.4. That's probably about the hardest thing you'll see. I think it gets easier from here, but that's just me being biased. Other than that, that's all that I have for today. I'll see you in the next video. Bye for now.